demo of a workflow that automates deep neural network training using remote resources. This is the big picture that we are working on. For some data experiment facilities like Slack, their data generation rate is pretty high. It is actually becoming so high, and that is challenging to save all the raw data to their local storage or stream the raw data to HPC center for real-time analysis. What we propose to do here is to use machine learning based segregation solution to analyze the data um, on the edge computing resources like near the data acquisition. So it was like motivated by that. We have some conventional method to analyze the data, extract information from the data, but those methods are either not easy to parallelize, or they are parallelizable, but we need HPC to run them, right? So which means that we need to stream the raw data to HPC center. Well, thanks to the development of AI and technique itself, and also the purpose-built AI chips to run the AI model, this AI-based segregation solution actually can be much faster than the conventional method, and although it may need more floating point operation, and the more AI model is more friendly to the purpose and build AI chips. That's why it can be more efficiently run on the AI chips, and thus much faster than the conventional method. But we still have problem here because we need to regularly retrain our model in order to keep up with the experiment condition change or the different experiments. Yeah, so we need to rapidly train the model, and because we don't want the experiment to wait for the model training, right? We need to train the model rapidly, and so that's why we propose to do this rainbow thing. I mean, and we have some HPC, and we have the some purpose-built accelerator like GraphCore, Cerebras, and GPU, this kind of things. But they are these kind of things need to be hosted on a data center. We cannot like put this kind of put a HPC near the beamline. It's either, I mean, yeah, it's not probably not very possible. Okay, so that's why in this demo we are going to automate a process that scientists and Slack, they can just initialize to train the model, and we should facilitate that. Like basically, they just need to click a button and tell us okay, where the data it is and where which code you should use to train the model, and then that's all. They just after that they just waiting for they're going to wait for the model to come back. It should come back in a few minutes, right? And we automate all these things. So this is the current implementation so far. Basically, the workflow has three components: and transfer the data from a point that the user specify to the data center, and then we request resources, computing resources from a data center, and train the model. Once the model is trained, we transfer the model back to wherever the user specifies, the scientist specifies, right? The building blocks we used for this workflow including Globes OS. That's like a user or scientist talk with the Globes need to authenticate with like a source or data source, for example, Slack data management system. Also need to authenticate with the Argonne data center, HPC center, in order to request using the resources. And if the destination for the model is different as the data source, we also need to do authenticate. I mean, but GlobalHost can do this on our behalf, and we only need to talk with GlobalHost, where we don't need to do that like manually for each of these. We only need to talk with Globus to do all the things. GlobalHost. We also use Globus file transfer service. As you may know, the training data may be big. So we need to efficiently move this data and reliably move this data to data center. And once the model is similarly for the trained model. And we use Funkes to interact with HPC scheduler to request resources and run our model training functions. And we use Globes Automate to manage all the workflow. Basically, and user will only need to talk with Globus Automate to like send a request, query the status, right? Okay, I will go through the code, the demo code. I mean, this is not the full code that a user needs. Users only need, or scientists, again, I use user and scientists interchangeably. User only need to have a part of this. I mean, here the source code, the code here, the demo here will include how to build the workflow and run the workflow. But for the scientists, they only probably care about how to run the workflow. Because once the workflow is built, they can just run it over and over again with different arguments, right? So we import all the libraries, and then we create a FuncX in order to FuncX client in order to register our training function to FuncX service so that to build the workflow. And here I will first run a hello world to check if the service is okay. The service is working well, and then we wrap up this training function. Well, this training function here is pretty simple because because of the limitation of Cerebras, we have to talk with Cerebras schedulers through system call. But for other platform, let's say NVIDIA GPU based solutions, you can even have your model definition here. You can define your model here. Yeah, but for Cerebras, we have to do it through a system call. So just basically you need to wrap up a function to run whatever shell script you need. Okay, so here we will build the workflow, and the flow was defined here in like this. Like we have 3 components, right? Transfer data, transfer training model, transfer model, and this very simple and easy dependency definition. Okay, and that's it. Then we build the workflow. Basically, what we do is we will register the flow we define here and to Globus Automate. Once we registered, we will get a flow ID. So after that, up to here, we only need to do it once. Once we get the flow ID, and then we are going to just in the future we can just run the workflow over and over again with different arguments. And this is how we build the work and the argument, right? Wrap up we wrap up all the argument in the dictionary. We basically make, in particular for this workflow, you need to tell me like where your data is, right? And which resources you're going to use, and what's the destination for the model. And also you need to, you need to provide both the Globus ID, and this is the ID for the endpoint ID, and also the full path to your model, or to your data to the model, and just a temporary workspace. So that's why for different runs, the user only need to change this part, right? For example, they want to use different they want to use different data, they want to use different source code, they just need to change it here. And then we can just run the workflow with then we need to do authentication here, just to authenticate Globus to do this. Okay. So as you can see, we run the flow, run this flow ID we gave, and also we give the input. This flow input basically is a dictionary that has everything we need. We wrap everything into this dictionary. So it will take a few minutes. Although I only asked to train the model for 200 steps in order to minimize the avoid waiting too much. And the model we are training here is the Bragg and that we developed for it's like a AI based surrogation model for Bragg peak analysis. It's actually more than 200 times faster than the conventional method, conventional pseudo Voigt fitting. Just using CPU, not using. If you can use GPU, to run a model on train neural network model on CPU or GPU is like seamless, right? It's very straightforward, and we can get like more than 1,000 times faster. Can be more than 1,000 times faster. But to train the model, if we use GPU, it will take around 3 hours. But the Cerebras we use for this model in particular is more than 30 times faster than a V100 GPU, which means that 3 hours on GPU, and if you use Cerebras, it only take like 6 minutes. And you need to spend a few minutes on data transfer, because like I mean the data transfer, the data size is big here, and around 30 gigabyte, but we have 100 gigabit link from Slack to Argon. Yeah, we need to pay a few minutes on data transfer, or also we need to transfer the model, but the model is pretty small. That's a few minutes, like probably in total should be like around 10 minutes, or should be less than 15 minutes, compared with 3 hours using like a GPU, and that you can use it locally, right? Still, which means that still worth to pay for the network and train the model remotely, right? Once the model is trained, I set the destination as here, as in my laptop. Laptop as the destination for the model. Once succeed, we should see something here is basically a TensorFlow checkpoint. We should see a TensorFlow checkpoint here. That has all the model weights. Yes, you can see the data are coming. Yeah, okay. Files are coming. Yeah. We can yeah. I run this workflow several times before. That's why we can see several checkpoints. It's not only one, like 400 step and 400, 620, 820. Yeah. So now this is the latest one. So yeah, this is from this flow goes from 820 to 1020. And you can see this shows flow status 60. So that's all of the demo. Thanks.